All right, so part 2 of our notes. Let's go to page 3 of this. So we were talking about arithmetic sequences. They have this common difference. We can represent them with tables, we can represent them with graphs, we can represent them in the lists of numbers, and so we can also represent them, like we said, with formulas, and that's really going to be the main part of Module 4, is using these formulas. So formulas give us instructions on how to find any term of a sequence, or how to find, since any term is also called f of n, how to find any output, that would be your output, for any possible n value or term. We'll also call that our input. Okay, so let's take a look. We've got 2 types of formulas. The first one is called recursive formulas. Recursive formulas give us 2 pieces of information. The first piece of information is the first term of a sequence. That's the first piece of information. The second piece of information is the pattern rule to get to any term in a sequence from the term that comes before it. Now, here's the key words. We've got to go from one term to the next. So we're looking at terms that come before and then building on that. So for example, f of 1 equals 3. What this is saying is that the first term is 3. Now here's the rule. Here's the pattern rule. F of n equals f of n minus 1 plus 2. Now what that's saying is add 2 to the previous term. That's all it's saying. So this f of n minus 1 piece, that just represents the previous term. Okay, so in order to find the 5th term, for example, you must extend the sequence one term at a time. So you have to go from term 1. So we know term 1, or f of 1, equals 3. So to go from term 1 to term 2, now f of n minus 1, if we're going to term 2, is going to be f of 2 minus 1 plus 2. So f of 2 minus 1, that's my first term. So what this means is my first term. And isn't that my previous term? Well, if I'm looking for term 2, my previous term is 3. So I take my previous term, 3, add 2 to it, and let's put a third column here, f of n. So 3 plus 2, my next term, my second term, would be 5. If I want my third term, I take my second term and add 2 to it. So my second term was 5. 5 plus 2 is 7. If I want my fourth term, I take my third term and add 2 to it. My third term was 7. 7 plus 2 is 9. And if I want my 5th term, I take my fourth term and add 2 to it. My fourth term was 9. 9 plus 2 is 11. So if I want to find my 5th term, I have to find term 1, term 2, term 3, term 4, term 5. That's kind of inefficient, especially if you're trying to find like term 100. That's not really going to help you because you'd have to find 100 different terms. But let's try a couple of these. So we want to find f of 4 if f of negative 1 equals 5. So here's my first term. And f of n equals f of n minus 1 plus 9. So to each of the previous terms, I am going to add 9. So here's how this works. Here's my term number. Let's make a table. 1, 2, 3, 4. I'm looking for term 4. That's this right here. Term number 1, that's this right here, is -5. And we'll call this f of n because that's our output. Let's do some work over here. So to find term 2, I take term 1 and add 9 to it. So -5 plus 9 is -4. To find term 3, I take term 2 and add 9 to it. So, whoops, that's +4. 4 plus 9 is 13. To find term 4, which is what I'm looking for, I take my previous term of f of 3, add 9 to it. My previous term was 13. 13 plus 4 is 17. So we could say this, f of 4 equals 17, or my fourth term is 17. Let's try number 2. Find my third term, f of 3. If f of 1 equals 20, and here's my rule, f of n equals my previous term minus 17. So let's make a table. Actually, let's try a list. We'll do a list. My first term is 20. Now my rule is to take my previous term and subtract 17 from it. So we could also do this. Take that term and subtract 17. 20 minus 17 is 3. Take that term, subtract 17. 3 minus 17 is, let's see, I'm now on the negatives, -14. And that is my third term. So I could say f of 3 equals -14. And there's my solution. All right, let's look at number 3. My first term is 2. F of 1 equals 2. My rule is I take my previous term and add 1/4 to it. Here, let's make a table this time. I'm looking for my fifth term. 1, 2, 3, 4, 5. So I know my first term is 2. So I'm going to write 2. And if I just add 1/4 to the previous term, 2 plus 1/4 is 2 1/4. 2 1/4 plus 1/4 is 2 1/2. 2 1/2 plus 1/4 is 2 3/4. And 2 3/4 plus 1/4 is 3. So my fifth term equals 3. Now I don't know if you realized it, but I showed you 3 different ways that you could figure out, using your recursive rules, how to find your term numbers. I showed you using this table up here. I showed you using a list. And I showed you using another table, kind of like an in-between the table and the list. So that's 3 different ways, because there's one more different type of formula. That's called an explicit formula. So with arithmetic sequences, we have recursive formulas and we have explicit formulas. Now, if we have a sequence, -5, 4, 13, 22, and 31, the explicit formula for the sequence is f of n equals -5 times 9, or sorry, not times, plus 9 times n minus 1. Now, here's what this means. Here's my first term, -5. See, here it is. So this -5 came from this -5. This is my, remember this guy? Common difference. What am I doing to get from one term to the next? I'm adding 9 to each term. Now, this does not mean the previous term. This means take your term number and subtract 1 from it. So for example, let's look at this example and then we'll be done. If we're looking for f of 20, my input, my 20th term, or my n value is 20. So we would say f of 20 equals, now my first term is still -5. So it equals -5. My common difference is still 9. Now my n in this case is going to be my term number 20. So I'm going to put 20 minus 1. This does not mean the 19th term. It means take 20 and subtract 1. 20 minus 1. So f of 20 equals negative 5 plus 9 times 20 minus 1. We simplified that to 19. We're still looking for our 20th term. Negative 5 plus 9 times 19 is 171. So then our 20th term would be 166. So the 20th term is 166. And that's how you do those. So if you want to try a few more of the explicit formulas, we can do these in class tomorrow, or you can try them for notes today. We'll have a lot more examples. But try these 3 in your notes, and when we come back tomorrow, we'll check them out and see how you did.